Since the last video, I did finish the rest of the assembly of this. And what I've gone ahead and done is added the rest of these ports that really connect to all the different ports on the MCU. And then I've also added in headers for 3 volt VCC and ground and a capacitor to go with that. Headers for the 5 volt and the 3 volt over here around the regulator. I've added a reset switch and then some standoffs. And I think that's about it since the last time. But at this point, this board is fully populated. I've also been able to go in and work with a programmer to see if I could program this, and I have had success with that. And maybe what I'll show real quickly is the components that I'm leveraging to do that. The first thing that I'm going to be using here is this. It's just a Freescale USB DM. And essentially the way it works is it takes in a USB connection here from the PC. And then I've got a header that I can then connect over to my board like so to program it. There's a slightly different header for just a variation of a pinout, but this is the header I'm going to use. And then I can plug in like this and I can program it from my PC. Now on the PC side of things, just to show you what I am using, I've been trying to update this page here that you see. This is just on my blog, and I had put a blog entry about MCU fun, and I'm working on the first of a series of MCUs. So this is this NXP MCU that I'm using. And I did list out what I'm using. So again, I've got this hardware, but then I'm going to use this Code Warrior version 11.1 from NXP. So that'll be the development environment that I'll be using so that I can do C programming or possibly assembly. So C and or assembly. And then I've had to find the drivers for this USB DM, and I grabbed those here and downloaded and installed those. And then I also installed their software for this USB DM, and there's a link here that I've posted. And that just gives some utilities, and one of those is actually quite handy that I'll be using quite a bit. The order of this matters, or at least number 1 has to be done first, because when you come in and install this software, number 3, it actually updates some of this Code Warrior configuration so that this USB DM works correctly. So if any of you are going to do this, just make sure you do the Code Warrior first. I don't know if the drivers and the software matters, which version or which order that you're going to go in, but I did drivers and then I did the software. And that's worked fine. So if I go back over to my workbench here for a second, and I'll just zoom back to this. So I have, this to program, which for now I'm going to disconnect that and set that off to the side. And I'm going to get this turned on. So I've already programmed some stuff on that. And I'm actually going to do a couple of things. First of all, I am going to hook up a speaker. And that speaker that I'm going to hook up, I'm going to generate some sounds off of. And let me go ahead and get that connected in. So I'm going to connect it to this header, which the very end pins are ground. So I'm going to really connect the speaker to a ground. And let me zoom into this. So the speaker is going to connect to a ground and then one of these port signals. And this is just a really inexpensive little PC speaker. The other thing I've done is I've grabbed this 1602 LCD and I'm going to connect that up basically and see if that will work fine, which I've tested this, so I shouldn't have any issues. And I'm going to go ahead and connect in the data lines. I'm going to run this in nibble mode, which means I'm only going to use 4 of the 8 data bits called nibble mode. But I'm going to go ahead and get that set of data bits plugged in. And then I also need to hook up some of the control signals. And those are going to go on here to 2 of the other bits on that port. So I've got a ground bit that's not used, or a ground pin, and then 2 pins coming off of a port on the MCU for controlling basically what I'm going to write to this. And I've got the read-write tied to ground, so it's only writing to this. I'm not reading back any configuration. On a lot of my other projects, I read back the status of the LCD when I try to write, just timing-wise, things like that. I'm not doing that yet in the code here. So I can only write to the LCD at this point. But I have those two control wires, and those are coming down here to the RS and the E signals on this 1602 LCD. And then my RW is going to ground. These LCDs typically run off a 5 volt, and so I'm going to go ahead and take this little breadboard and tap it into the nice little 5 volt header that I put on here. And so I've got the positive on the upper side of this. So my positive is the brown, and I'm connecting that down to positive on this little breadboard. Okay, so I've got a speaker hooked up, I have an LCD hooked up, I've got power hooked up, and then I'm going to use this same little board I've been using to supply 5 volts into this MCU board. And so let me go ahead and get that hooked up. Okay, so at this point I will bring in power up to this little board just so I have a switch to flip here. This is just going down to my benchtop power supply, bringing up about 5 volts. And then I'll take that 5 volts and bring it over to this breadboard also from my little PCB. I've got my signal set up to connect to the LCD here, and I've got this little speaker connected in also. And as a reminder, I have 3 LEDs down here in the corner of this board. And what I'm expecting when I turn this on, the way I've got it programmed, is you're going to see it's going to write to the LCD. It's going to cycle through these LEDs with just a binary counter. It's going to do that twice. And then it's going to play some tones, and then it's going to add a little bit more to the LCD. So I'm going to go ahead and flip this on. Let me just double check I've got all my power orientation correct. That'd be the last thing I'd want to do is reverse polarity anything here on anything, but let me go ahead and turn that on. So I get my hello world. You can see my LED cycling. And I don't know if my noise reduction on my mic setup will take out the audio sound, but I'm going to go ahead and turn it off and turn it on again, and hopefully that audio sound comes through okay. And at that point, I'm getting my tones, the LCD fills in, and then it adds a little smiley face at the end. The LEDs there are rotating through just fine. And let me show you how I'm actually connecting to and programming that. Now I notice I must have caught this potentiometer when I was picking it up. I'm just going to adjust that so it's a little bit brighter again. Now to actually program this, then I grabbed this programming device, and I'm going to go ahead and plug it into USB real quick. And maybe I'll zoom out on the camera. So I've got this just plugging into USB on a hub to my computer. And then I have this ribbon cable, and it's got a notch on one side. I did mark that on my PCB, so maybe if I do another version, I can silk screen that on there to make it clear, or put a box header so that I can't put these in backwards. That would be nice. But I'm going to go ahead and plug this in. Okay, and when I plugged it in, I bumped the reset switch, but I can also validate that my reset switch over here works fine. So when I press that, it resets this LCD, it goes through the LEDs, plays the audio tones, and then completes that there. Now this device seems pretty simple. Really the only thing I've had to modify or make sure I had set right is there's a 5 volt or a 3 volt option. So I set it to 3 volt. Just double checked that this pin out matches the pin out for my little programming header, and that is the case, so that all worked fine. And then I end up with this. Now on my computer, let me pull up the software I'm using. Here is this Code Warrior, and what you're going to see here is that I have a main.c file. And in that, there's a bunch of things, and there's some sound code that I'm working on. That's not what I'm using right now, but I'm going to go down to the main So when this comes on, this is what it starts running. And so the first thing I do is I just set all the ports to output only. And then I initialize the LCD display. I write the hello world. I jump to the second line, second character, and then I add this from REHSD. I then iterate through and set values on my LEDs. So I have a procedure where I just tell it basically a value, and then it's going to show that value binary-wise on the LED, or those 3 LEDs. And then I can delay in between switching LEDs, so how fast does it move them. And then after that, I run a little procedure called run audio to, and that plays a sound, does a delay, plays a sound, does a delay. And those are quick little routines I wrote. So if I just go back into this, all of this LCD stuff I actually used from one of the books I'm going through. And that is this book down here, HCS08 Unleashed. And in that book, there's some nice sample projects, and I have a link here to download the code from the author. And basically, there is sample code to control the LCD. And I've worked with these LCDs a lot. It's a C version ready to use. All of my code for those is in assembly. So I just leveraged the C code from this author. And then same with, there's an audio project, but that ends up being quite a bit more complex than what I implemented here. And it was written for a slightly different MCU. So I've got some porting to do to see if I can get that working on here. But when this comes down to all the LCD stuff, I'm using that author's code to do that. Then I get down to where I set my LEDs. And that's code that I wrote. It just simply says, well, what value do you want the LEDs? And it sets the LED values accordingly. And then it does a delay. And the delay function is something really simple. It's just a simple little for loop. And then this run audio 2 that I have, when I go to that, I just wrote a quick little play sound routine, which you can see right up here. Which basically I pass in. This isn't real accurate, so don't get too worried about the code here. I just wanted something to at least get going quickly. But I pass in a pseudo frequency and a pseudo duration, just kind of a ballpark type number, do a couple quick calculations, and then manually generate essentially a square wave to generate that audio. And so if I change the delay between the low and the high of the wave, of course that's changed in the frequency. And then how many times I run through the for loop is how long it's going to hold that frequency. So really, really simple. The other code from this other author gets into much, much more. And that's what all this code up here is to be able to go in and actually play songs. And so there's a bunch of songs where all the data is ready to go here. I just have to figure out a couple things that I've not been able to figure out yet in getting that code to run on this specific MCU. If I can get it to run on here, I would assume I can, but I'm not there yet. But once I'm done with the code, then I can basically just come in here and build it. And so I've just been using the keyboard shortcuts, but it's Control B. I just say build, and then that goes through and does a build. And at that point, if I just want to simply write it to my MCU, I have this other utility. Let me pull it up. This came with that software for the little programmer, and it allows me to detect my chip, and so it'll go out and read and detect what I have for a chip there. And when I do that, you'll probably see that I saw that it lit up some of the LEDs. When I did that, I can see some of the communication LEDs here, but then I can just say load from a file, and this is the file that is just basically the output of this, what you see in the background. So I can say load a hex file, and down here I'm going to say load that file into the MCU and start running it. And so I do that, and it's done. And I can see over here it's cycling through my LEDs, and then it's playing my audio, and then I get the little smiley face. So it actually did that. Now if I wanted to change something, for example, I want to change some of those tones, I could come back to my code, come back down to where I have the tones, and let's just say at the end of it, I'm going to go ahead and play 3 more notes. So I'm going to add 3 notes here real quick at the end. 1, oops. So play a sound and do a delay. I'll do that 1, 2, 3 times. And I'm going to pick a higher frequency. And something in the middle. And like so. And so that's 3 quick notes at the end. And from there, I'll just hit Control S to save it, Control B to build it, and it builds it. And I get some warnings, and that's just to do with data conversion. That's going to drop some decimal point stuff, and there's something else in this other code that I was pulling in. Nothing critical though. But now I can come over here and just say load and go again, read the file. And it's starting up again. I see my LED cycle there. And then at the very end, again, I don't know if my microphone's going to pick that up, but it added those pretty high notes. And if I say, okay, that was too high, maybe I want to have some lower notes. Maybe I'll just take this down to 300. And 1,000. And 700. So I'll save it, I'll build it. And then I'll just tell this other tool, yeah, just go ahead and program it again, reload the file. Again, I can see it's going through its startup. And now I hear a different sequence of tones. So that's all working really well. Now, if I want, I can also debug it. So if I do come in here and say run, I can say debug. And I've not had any problems debugging. Now, when I try to get out of debugging, it seems like this is the type of thing I run into. So I must have done debugging before on here, possibly in this session. And I get an issue where it can't connect to the MCU. I get this message. Now, a quick fix for that is I can close this application and reopen it. But there's got to be a better fix than that. So I'll have to look into it as far as what do I need to do to be able to exit out of debug and not have it lose control or get something back that it's supposed to be getting back maybe from the MCU. Seems like it's more of an issue between that Code Warrior software and maybe this programming device, but I don't know for sure. So I'm just going to open up this Code Warrior again. And when it does come up, I'll jump in and start up the debugger and just validate that that works okay. So when this does come up, it takes a little bit to kind of get back in here and have everything load up correctly. I don't know if it's trying to do communication to the device or something else, but it's a little slow when I try to reopen it. Maybe takes another 5 or 10 seconds here. So I'll just give this a second to finish whatever it's doing. Okay, so now let me do a run, and I'll go ahead and say debug. And I can now see that I'm in debugging. I've got the breakpoint set here. Now what's on the LCD was left there from the last time I ran it, and I know that because of the smiley face. My LEDs are off. I'm not hearing any audio. But then I can come up here, for example, and I can say, okay, go ahead and let's just step over this code. And so I'm setting all the ports to output. And then I'm going to go ahead and initialize the LCD display. And you can see here that it cleared it. And then I'm going to go ahead and continue on, set the cursor to 0, 0. I'm going to say write hello world. And you can see that writes up quickly. And then on the second line, I will write out this additional text. And then I go through this loop where I set the LEDs. And so I'm going to go ahead and just do a step over. I'm not going to step into those, but the first one sets them all to 0 and or sets it to 0. So you see no LEDs. The next one then should go up to a 1. And so there you see that LED lit up. And every time I go through this, I'm just incrementing. So there's my 2, there's my 3, etc. So I'll just keep going through this. Okay, so then I have them all turned on, and at that point, going to do it one more time because I put that in a for loop to run through that whole sequence twice. And I'm doing that just so that when I do reset it, I see those cycle. It kind of lets me know that it is going through initialization code. And two times through this is kind of about right for me to just pay attention to it when I do cycle it. Okay, so I'm done with the for loop, and now I'm going to go ahead and say run the audio. And I'll go ahead and just run this whole thing and let it play the audio sounds here. Okay, and then at that point, I'm down to where I'm going to write out the smiley face, and I do that. And then I kick into basically a while loop. So I should be able to just say, well, okay, resume, just let it run at this point. And I'm done. And now what I should be able to do is to stop this now. And then once I stop it, make a change, build it, rerun it, or even right now, I should be able to just turn around and say, okay, I'd like to run it again. Either just run it or debug it. And if I say debug, this is where I run into this. Okay, once I've done it once, it struggles to reconnect. But I can use that other utility, this one here, and I can program and run this load and go as many times as I want. So that tells me it's something maybe more on the CodeWarrior interfacing with this programmer, that at the end of the debug, something's not getting released correctly. So if anybody has any quick solutions to that, let me know. That would be great. Otherwise, I'll dig into it and see what I can do. Maybe you can run a little script at the end of a debug that resets it or something if there's some issue there. Could be a firmware version, could be a driver version. I'm not sure. But that's pretty much where I'm at this point. So I can come in here and reset this. If I want to disconnect the programmer at this point, of course, it's programmed, so I don't need the programmer on here. So I can go ahead and pull this off and just get rid of it off to the side. And now I can hit reset here. And the only thing I'm really doing is feeding it 5 volts from this. So I could easily get 5 volts from something else. That could even be a little simple USB connector for power, or just a little wall wart type of thing. This all seems to be working well, other than the getting out of debug mode in CodeWarrior. But like I said, that's not a gigantic issue, because for the most part, I find myself going back to the code, building it, and when I build, if there's errors, that tells me right away in the IDE here. And then as soon as I'm done building it, I just flip over here and say load and go, and off it goes. And so that's been good. So that's where I'm at with this guy. So I've generated some audio. I've controlled the 1602 LCD. I've got just basic port output going to some LEDs. And now I'm going to just kind of dig in a little bit more in the manual for this. There's so much that this thing can do that is foreign to me. So I'm going to start seeing if I can learn how to work with more capabilities of it, other than just doing simple things like what you're seeing here. So we'll see what I learn from this. And then maybe while I'm doing that, I do need to get back over to maybe working on some of the logic for my 486DX2. And I do probably want to order up the next PCB that I might be working with in this series. So right now I'm on this NXP. But I think the next one I'm going to try to work with is either this Texas Instruments, or is it Renesas, if I'm probably pronouncing that incorrectly. But one of these two, I have both of these, these MPUs that I can work with, MCUs, sorry. So I've got both of these MCUs I can work with. And then after that, I have some 32-bit ones that I figured I could work with. I have this Texas Instruments TMS, and then I've got a microchip that I could do some stuff with. And I might go over to my PSOC 5s that I've been using, and they've got, essentially MCU capability. So I could maybe start learning how to use it a bit too. And then one of you had suggested, well, maybe at some point also get into some FPGAs. And I've done a little bit with some of the FPGAs before, not this Lattice FPGA, but maybe that's one I'll experiment with at a later point. And of course, that's not an MCU. It's kind of, it'll be maybe the next step of these types of chips, though, that I might try to work with and learn more about. If any of you have any input on any of these, if there's some that, or maybe out of these four, the two TIs, the Renaissance, and the microchip, if any of those are of more interest or less interest, I'd be curious if anybody has any good or bad experiences. But I think I'll be working on one of these two next, probably the TI one, unless I get into it and find there's problems with that. So I think that is it for now on this specific MCU. More to come later as I maybe learn more about it. So it might be a bit before I come back on this one because I just have a lot to read and experiment with. And then if I get a PCB ordered up for one or two of these, that'll again take a few weeks for that to come in. No hurry because I'll be working on this, and somewhere I still want to get back and do some stuff on my 486 using a PSOC, the PLD functionality in there. But that's it for now, folks. Thanks for watching. Thanks for all the feedback. I did appreciate all the soldering tips in the last video and just all the other tips that I get as I go. So please keep those coming. Thank you much.